Number one, these are all about writing equations. And the first thing we want to realize that it's talking about perpendicular. And so once it's perpendicular, we have to acknowledge that the slope that we use, if this slope is -3/1, the perpendicular slope is going to be positive because it switches the sign, and then we flip the fraction. So that's why I wrote that 1 under the 3, so I could see that that original slope was indeed a fraction that can be flipped. So now we're just going to use this slope with this point. And that's going to look like y equals mx plus b. And I'm going to get my y and my x value from this point. My slope is going to come from the perpendicular slope. So when I substitute this all in, it'll be 5 equals 1/3 times x, which is -2, plus b. So we have everything but the b value. So now we can just solve that equation for b. When I multiply here, that's going to be -2/3 plus b. And then we want to add 2/3 to both sides. So that means b equals 5 2/3, which is 17/3. So putting that all together now, here's our slope and our b value. So we have y equals 1/3 x plus 17/3. Any questions on that first one?
No.
I'm good.
Okay.
Yeah.
Number 2. The only difference about number 2 is we have this idea that now it's parallel. So that's actually less work. Even if you didn't realize that, you could get away with doing this problem correct because we're just going to steal this slope off the equation. So I'm going to use the slope of 3/5. And I'm going to use this point. So for y equals mx plus b, the y value is -2. The m value is 3/5. The x value is 15 plus b. So the way that I do this is I do 15 divided by 5 is 3. And then 3 times 3 is 9. Is anyone struggling with not having a calculator at home? I know like TI has released like a free download to use an online version of their calculator. And there's some other apps that you can download as well. Desmos has a calculator that you can use as well. Subtract 9. So we have b equals -11. So y equals, I'm getting my slope that I chose, and my new b value. All right, we're going to the next page if we don't have any questions there. So for this problem, there's two ways that we can show that these lines are parallel. The first way is we can show that their slopes are the exact same slope. So they're not going to be gradually getting closer to each other. They'll always be the same distance apart. So we're going to find the slope of LM. And we're going to find the slope of OP. And our slope formula is M equals y2 minus y1 over x2 minus x1. So I'm looking up here for my x and y values for LM. I'm going to do 4 minus 6 Do you guys hear these birds behind me? 4 minus 6, 2 minus negative 4. So 4 minus 6 is negative 2. 2 minus negative 4 is 2 plus 4, which is 6. So that's a negative 1/3.
Mr. G.
Yes.
So I did y2 minus y1 divided by 2, and then I did x2 minus x1 divided by 2, and I got the same answer. Is that right?
What do you mean divided by 2?
So I was helping one of my friends in a lower grade with the work, and I couldn't remember the formula. So I looked it up, and I found y2 minus y1 divided by 2, and we used that, and it ended up working.
What did you get? You got negative 1/3?
I did.
That is interesting. It seems like, I mean, the midpoint formula is like this. But we're not doing midpoint here. So you weren't doing something like that, were you?
No, I did as two separate equations. I did 4 minus 6 divided by 2 equals negative 2 divided by 2 equals negative 1. And then I did 2 plus 4 divided by 2 equals 6 over 2, which is equal to 3. And then I got negative 1/3.
I have to say I've never heard of that strategy before. It seems a little bit more complex. If it works, it works. I'm not going to tell you not to use it. Did it work for the bottom one as well? The bottom slope?
I got.
We're going to do this
M
one.
equals. Yeah, I'll tell you if it works after we do it.
Okay.
Thank you.
I thought you were going to say you did it the other way. You did 6 minus 4, negative 4 minus 2. That would be fine. You're just going to get positive 2 over negative 6. You're still going to get negative 1/3 if you do it that way.
Okay, yeah. Apparently I did it a completely different way. We'll see if it works for the other one.
Okay. All right, for OP, I'm going to do negative 3 minus negative 1. And then I'm going to do 5 minus negative 1. The only thing you have to worry about with slope, you can do it either way as long as you go in the same direction for the x and y. I went from here to here. So it establishes my direction. Therefore, I have to do 5 minus negative 1. So whatever you just establish as your y2, you have to use x2 from the same point. That's the only thing you have to watch out for. So negative 3 minus negative 1 is negative 3 plus 1, which is negative 2. And then 5 minus negative 1 is 5 plus 1, which is 6. So
yeah, I got the same answer doing what I did.
There you go. I'm curious to see where that what that looks like. Feel free to take a picture of your work and just email it to me. I'm curious to see what that is.
All righty, will do.
Okay. All right, for number 2. So here's where a big mistake will pop up. When we look for the distance being equal, we want to make sure that these lines are not getting closer together. So the distances that we're looking for are right here. So we're looking for the distance from L over to O and from M over to P. So we're measuring the gap between the two lines and saying that it doesn't change. So the distance formula that we're going to use is D equals x2 minus x1 squared plus y2 minus y1 squared. So from L to O, it's going to be D equals -4 minus -1 plus 6 minus -1. So inside those parentheses, we get -4 plus 1, which is -3. The other parentheses, we get 6 plus 1, which is 7. So that's going to be 9 plus 49.
And that first in the first, I don't know, square box, it doesn't matter where those go, right?
Are you talking about right here?
Meaning, yeah.
Did you do -1 minus -4?
Yeah.
Yeah, that's fine. You're just going to get +3 in here. And it doesn't matter because you're going to square this anyways, which is going to basically cancel out that negative regardless.
Okay.
Yep, doesn't matter. And you can just leave it like this. We're just going to try and see if the next one ends up being the square root of 58.
Yeah, that's what I got. Thank you.
Good. All right, the next one, you're going to start seeing that these numbers will start being the same. So we'll do 5 minus 2. You could do 2 minus 5. It doesn't matter. And then -3 minus 4. That's 3 squared. Notice how I kept that 3 in parentheses. It doesn't matter since it's positive, but up above, since that's negative, those parentheses are very important. So this is actually a good example, RJ. Notice how up top, it's -3 with a +7. Down below, it's +3 with a -7. When you square those, it really doesn't matter. Unless you type it into your calculator wrong, without the parentheses, you'll get something different. All right, now remember, your quiz is going to be on Schoology. Not really sure what this problem will look like on there. Obviously, I can't have you guys show work, so that's to your advantage. So just make sure you understand the idea of what we just did. We just showed that the slopes were the same and the distances were the same.
So if we put it in the calculator and we don't use parentheses for like -7 squared,
yeah, you'll get negative.
Does that
49.
mess it up?
Yeah, you'll get -49.
Okay.
Because the calculator is only going to square the 7, leaving that negative out front.
Oh, okay.
We needed to say -7 times -7. Bring the negative along with the square.
Okay, I understand now. Thank you.
Yep. All right, so I imagine this will be like a matching part of the quiz. So it says sketch the graph of each solution possibility, what it would look like. So when I say sketch, it means I don't need to see like an X and Y axis. I don't need to see numbers. I just know if there's one solution, those lines need to cross. They don't have to be perpendicular. They just have to cross. No solution means they'll never cross. They're parallel. Infinite solutions means they're the same exact line. Maybe that would make sense if it's purple. So that's kind of like the one RJ asked me to go over. I had you guys match up the algebraic system. So you guys looked at the two equations and matched it up with their type of solution. This would be matching up what the graph looked like with the type of solution. It could be asked both ways. Because number 5 and 6, it's actually asking you now to create something that has no solution. Meaning, write me two equations that are parallel. Any two. So that would be something like y equals 2x plus 1, y equals 2x plus 3. Okay, easy enough there. Don't overthink that. Just make it as easy on yourself as possible, whether it's like a fill in the blank type question or it's a matching question. 6, create a system of two equations that has infinite solutions. So that means that the equations would be exactly the same. Y equals 3x plus 1, y equals 3x plus 1. Now, it could be visually obvious like that, but keep in mind, it could also be a multiple. What I mean by that is, let's say it was x plus 2y equals 7. So it's not in slope-intercept form. It could be 2x plus 4y equals 14. I just doubled everything. That's the same exact equation. It just looks a little bit different. That's like saying the fraction 1/2 in 3/6. It's the same fraction. It's just, it's scaled up a little bit more.
Could you stay on this page for a second?
Yep.
Thank you.
Want me to zoom out? Is that better?
I just needed to see the bottom part, because if I can look at the could be a multiple part just a little bit, I think I can understand it a little
Go
bit.
ahead. Yep, I'll leave it there for a second.
Don't worry, it's needed. I think. Yeah, it's needed. I know. I don't know what would be this.
So this is basically just like one equation can be divided by 2 to get the other one?
Or multiplied by 2 or 3 or 5. As long as every part is multiplied by the same thing.
Oh.
Just like
okay,
in a
thank
fraction, as long as the numerator and denominator are both multiplied by the same thing, you create an equivalent fraction. It's the same idea.
Alrighty, thank you.
Yep. All right, number 7, graphing. Again, I'm not sure with this question how it's going to be presented, such as multiple choice or fill in the blank or matching, but we'll just go over the idea of what I'm looking for here. So I'm going to start the first one at -1. And then the slope is 3/1. So we're going to go up 3/1. I'm going to fill up my whole graph with that idea. And then I run out of room there. So I'm going to go down now. You don't have to draw a line. So remember how I said in class, that's like us setting traps to see if the next equation lands on any of them. So the next one's going to start at +3. And this slope is -1/1. So down 1/1. And we land on it right away.
Okay. Mm-hmm.
So the solution is 1, 2.
Yeah, you asked me if I had graph paper.
I was just asking, I don't have to.
Is everyone okay with where that 1,
Mom, you're on
2
camera.
came from? That's the
We're
coordinate
there.
of this point.
Stop it.
An x value of 1, a y value of 2.
Thank you.
Yeah, and I'm still my naked grade. You tell me stop it. You shame me your mother?
What? No, I was like, forgiving me.
No, I didn't show in my front.
All right, the next one. I'm going to start at this -2. And the slope tells me to move up 3/2. And then I'm going to go down in the other direction, down 3 to the left 2. And then I run out of room. The next equation, I need to do a little bit of work. I'm going to subtract my 6x to the other side. That's going to leave me -4y equals -6x minus 12. Divide everything by -4. So y equals that. This part right here simplifies down to 3/2. Plus 3.
Could we do 1.5 for 3/2?
You can, but since we're graphing, 1.5 is going to tell you to move by 1.5 on the graph, and that might not be the best thing you want to do. 3/2 is a nice rise and run.
Oh, right. Okay.
But if you were working with it algebraically, let's say with the substitution or the elimination method, absolutely.
Okay, thank you.
Okay. So 3 over 2 tells me to go up 3 over 2. And I run out of room. Down 3 over 2. Does it seem like I'm getting closer at all? We should notice that the slopes are the same. These are parallel.
Beautiful.
So no solution. Any questions on that?
I'm good.
Okay.
Good.
All right, now let's look at these algebraically. Substitution method means that I want to substitute one equation into the other equation. So we always want to look for one of the equations to say that this is what y equals. Once we have that, we can substitute that in for whatever it says that it represents. So if this said x equals, we would plug it in over here for x. So I like to take my time. I take out the y, and I just say whatever y is, I'm going to put it in those parentheses, and I'll come back and do that. It's just my preference. I like to see it like that first, and then I come back in and put in my value, because those parentheses are very important when it comes to the distributive property. So that just kind of forces me to use parentheses when I do it that way.
To rearrange those, is it?
Say that again?
To rearrange those equations, is it? Or no? To make them y equals mx plus b, or no?
In this case, we didn't have to. But it's possible that you need to, that you can.
Hey, Johnny.
Yeah, Paul.
Your iPad dying. Your iPad.
It's at 23. It's okay. I've gotten through a whole class with 10%. So I think you see my laptop right now at 38%.
Yeah, you need charge.
I know. Well, I'm outside. I have nothing to plug it into at the time. So my next live session might be from the kitchen. All right, so we're going to distribute right here. Whoops, don't like that. So this is 4x minus 2. Plus that other 2x that was in there earlier equals 22. My like terms, we have a 4x and a 2x, so that becomes 6x. I'm going to add 2 to both sides. That gives me 6x equals 24. And to solve for x, I divide both sides by the 6. So I now have an x value. So when I do the substitution method, I always try and start with that box because then I know I finish with that box as well. Because that box is saying this is what y equals. We just don't know what y equals because we didn't know what x equals. Now we know what x equals. So y equals 2 times 4 minus 1. Y equals 7. So if x is 4, y is 7. Remember, that's the point of intersection. So if I was to graph both of those lines, it would have one solution at that point. That's where it would intersect. Give you guys some time to look at that. Make sure you write that down. If you didn't do the homework quiz yet, make sure if you want to come back to my office hours in the afternoon and ask questions, we can go over your homework quiz. Just make sure we're not going to do the homework quiz together. If you have homework questions, we can do that. But if you want to do the homework quiz and then ask questions about your homework quiz, kind of like RJ did, that's perfectly fine. Your quiz on Monday, keep in mind, you can take it any time of the day that you want. So even if you guys wanted to do both of my office hours on Monday, go over your homework quiz on Monday, you can do that as well, and then take your test later on in the evening. You guys kind of have a lot of flexibility to do that. All right. I didn't skip one, did I? I did skip one. Okay. Number 10. There's actually two number 10s. This is the first number 10, the right number 10. So this says to use the elimination method. So when we do the elimination method, we want to eliminate one of the variables. Now, you can always eliminate either of the variables. If you have a thing that you like to get rid of the x's, get rid of the x's. If you always like to get rid of the y's, eliminate the y's. But sometimes there is a shorter route to take. I always look for the singular variable because I can turn that into anything I want because there's technically a 1 there. So I can multiply 1 by any number to turn it into whatever I like. And we want to turn it into the coefficient above. I can't turn the 3 into the 4 or the 4 into the 3 without multiplying both equations by something. You can do that if that's your preference, but the faster route here is to multiply the bottom equation by 3. You can multiply it by -3 if you want. I know that's a strategy that's been taught in the past, maybe back in integrated algebra 1 or integrated algebra 2. But I just know multiplying through by negatives causes a lot of mistakes. So that's going to become 9x minus 3y equals 30. A mistake that happens here is don't forget we got to bring it all the way over to this side as well. Also, take your time and rewrite your two equations. We're keeping the 4x minus 3y. And now we have a new one, which is 9x minus 3y equals 30. Just take your time and clean that up. Give yourself a fresh start. Now think about what we said earlier about multiples of equations. That purple equation, we did not change anything about it. It would be the same line as if we graphed the original one. We just made a multiple of that equation, so it benefits us in this strategy. We technically didn't change anything except for how it looks. So now we have to keep in mind, what do I want to do to cancel these out? Is it -3 plus -3 or -3 minus -3? And anytime the signs are the same, you want to subtract them. So take your time here. This is 4 minus 9, which is -5x. -3 minus -3 is 0. -12 minus 30 is -42. So this is what's been eliminated. We no longer have a y term. So that's just -5x equals -42. Divide both sides by -5. We get x equals 8.4.
Can you show the whole page again, please?
Yes.
Thank you.
There you go. Yeah, and if I lose you somewhere, you need me to zoom out, just go ahead and ask.
Thank you.
Yep. Now, RJ, you asked before, can we solve an equation, like rearrange it? That is an option. Like if we wanted to do the substitution method, we could solve this for y and then plug it in up here. We could always do either of these strategies. Sometimes it's just it makes a little bit more sense to use a strategy based on how the problem is presented. So now we have to take this x value. We don't have a box to plug it back into like the substitution method, but we do have equations. Now I could plug it in here. I could plug it in to my new purple one. I can even plug it in back in this original one. You basically have 3 equations to choose from. Whichever one you think is going to be the easiest. I really don't see one being easier than the other right now. So I'm going to go with that top one. 4 times 8.4. Minus 3y equals -12. So that's 33.6 minus 3y equals -12. I'm going to subtract the 33.6 from both sides. So we have -3y equals -45.6. And then I'm going to divide both sides by -3. And we get 15.2. So our solution is 8.4 and 15.2. I'll just pause right there for a second so you guys can take a look at that.
Johnny,
Yes, Paul.
you see number 12?
Yeah, we're going to skip number 12. So I think we actually have one more problem to do together.
That's it.
All right. Does anyone need me to go back or pause back there a little bit longer?
No, but
Go ahead.
this one.
Yeah, there's a mistake.
This one I need a lot of help on.
There's a mistake on this one. First off, it should be number 11, not number 10. In this equation, actually, Paul pointed this out to me yesterday.
It does. You're funny.
Thanks, Paul.
What's his math?
So this should be negative x
Oh, I
plus
confused.
y.
You Johnny.
Yes,
I
Paul.
confused. You told me negative plus y. You missed 7.
Yeah, that's what I just rewrote. Negative x plus y equals negative 7. That's what it should be.
Yeah.
Good. So if you look at these two equations now, this bottom one, hopefully it's starting to jump out at you that it's just a multiple of this top equation. Every one is multiplied by 3. So if I multiply that by 3, I get negative 3x plus 3y equals negative 21. It's the same exact equation. Now, it might take you a little bit longer to realize that. Maybe you haven't realized it yet, and you're going to subtract all of them. You're going to get 0x plus 0y equals 0. So you're going to get 0 equals 0. And that's a true statement. 0 does, in fact, equal 0. Since they're the same exact equations, our solution is infinite. Infinite solutions. Now, you can have a problem that also ends up being false, like 0 equals 7. Then that would be no solution. But this one is true.
Mr. G,
Yes.